Hi students, welcome to my channel CSIT Tutorials by KanyaKumari. In this video we are going to discuss what is a circular queue data structure. What is a queue data structure? So queue data structure is a first in first order data structure in which we can perform the operations like NQ and DQ. In the same manner here also this is a first in first order data structure. We can perform NQ and DQ. Okay, so then why we should learn this circular queue data structure? What are the disadvantages of simple queues? How that disadvantage we can overcome in circular queues? So now if you consider a queue data structure, see, for example, queue size is 5, 0, 1, 2, 3, 4. For example, if this is the queue, 10, 8, 16, 14, 3. So now in this situation, rear is present here, front is present here, -1. If you have not seen this queue data structure, please watch the queue data structure and see the circular queue. Then it is easy to understand the differences between queues and circular queues and the advantages of this circular queue. Okay. Now, if the elements are inserted like this, then rear is present in this position, front is present in -1th position. For example, now I have performed some DQ operation. So then the first element will be deleted. Again I have performed a DQ operation. Second element will be deleted. So that means the front will be moved to here. Again I have performed another DQ operation. So now again front is incremented and 16 is removed. Then the queue data structure is queue size is 5. So then the elements present here are 14 and 3. Rear is present here. Front is present here. Now I want to perform NQ operation. See, in simple queues, here queue full condition is rear equal to max -1. So if in simple queues, queue full condition is rear equal to max -1. See, here, now if you observe, now I want to perform NQ, some element I want to insert 1. So now here rear equal to max -1 insertion is not possible. But there is a space to insert. Though there is a space to insert, we can't insert an element into the queue, which is a limitation or a disadvantage of simple queues. That means reusability of memory. Reusability of memory is not there. Reusability of memory is not there in simple queues. Why? Because here rear equal to max -1 simply it prints queue full condition. Okay. So reusability is not there. So that's why that is a disadvantage of simple queues. To overcome that, what we will do is, so whenever there is a space to insert and rear is present in the last position, we will move rear to 0th position, which is nothing but a circular queue. Simple. I am telling you the point. Though there is a space to insert here, yes, there is a space, and the rear is present in the last position, then we are moving rear to 0th position. That is called as circular queue. Okay, so now in this, see, for example, this is the situation. 0, 1, 2, 3, 4. See, in circular queue is represented like this also. or you can represent like an array like this also, no problem. So now queue size is 5. 0, 1, 2, 3, 4. What is it? So if there is a space to insert, if it is rare is present in the last position, we are moving rare to 0th position now. So now here also, so now 10, 8, 16, 14, 13. These are the elements present. Now I have performed a DQ operation. So now what will happen? This will be removed, this will be removed, this will be removed. Okay, and rare is present here. And there is a space. See, the last position. What is the circle? Circle is nothing but the starting and ending are present here. So here it is a last position. So after this we can insert in 0th position. In the same manner here also we are representing like this. You can represent like this or you can represent like this. No problem. Okay. So now here in circular queues, how can you perform NQ operation? NQ operation we can perform like this. So here some space is there and you want to insert, then rare is moved to 0th position and then elements are inserted. Like that NQ operation is performed. I am repeating the point. If this is the case, so here rare is present. So now there is a space to insert and rare is present in the last position. Then move rare to 0th position and then insert the element. Okay. If rare is not present in the last position, that behaves like simple queue. In simple queue, how we can perform NQ operation, increment rare position and then insert the element in the rare position. If rare is present in the last position, then moving rare to 0th position behaves like circular queues. If rare is present here, here, here in these positions, then it behaves like simple queue. Then NQ is performed like rare incrementation and then inserting an element into the queue data structure of rare position. Okay, now similarly, how can we perform DQ operation? So here also, for example, these are the elements 0, 1, 2, 3, 4. Okay, so now you know already the DQ operation I already told you. So if you have not simple queues, so please watch simple queues concept and see this is circular queues video. Suppose I want to perform DQ operation 8, 2, 16, 3, 14. Suppose these are the elements present in the queue. Okay, so now if this is the case, front is present in -1 the position, rare is present here now. Now I want to delete. If a front is present in these positions, it is behaving like a simple queues. If a front is present here, again we will move front to 0th position. What does it mean? Now, for example, 0, 1, 2, 3, 4. Now, 8, 16, here rare position is there, here front position is there. Okay, then how can we perform NQ operation? As rare is present in the last position, we are moving rare to 0th position. Then we can insert. Now, queue data structure is 0, 1, 2, 3, 4. So 8, 16, some 4 I want to insert, 4 I have inserted. Okay, now this is rare position. Suppose NQ of 5, NQ of 5, now 0, 1, 2, 3, 4. Now I want to perform insertion operation. As rare is present here, na. See what happened? Rare is present in the last position. We are moving rare to 0th position. But rare is present in these positions. How can we answer? Simply increment rare, which behaves like a simple cube. Okay. So now 5, 4, 8, 16. Okay. Now I want to perform DQ operation. I want to perform DQ operation. How can I perform? In this situation, front is present here. No? Front is present here. Now, if front is present in these positions also, it behaves like a simple queue. That means simply front will be incremented and this element is deleted. Another DQ operation I want to perform. Front is present here now. That is not in the first position. Not in the first position. Then simply increment front and then delete. Now I want to perform DQ. If you observe, front is present in the last position and Q consisting of some elements. Then front is moved to 0th position. Okay, then this element will be deleted. Then the Q consisting of the elements 0, 1, 2, 3, 4. Okay, this is removed now. So fine. Here it is rear and here it is front. Now front and rear are present not in the last position. Whenever you want to perform NQ and DQ operation, it behaves like a simple Q. If you want to perform DQ operation, simply increment front, delete it. And here now again you want to perform DQ operation, so deletion is not possible. See, observe very carefully. So there is only one important point here. If 0, 1, 2, 3, 4. If a space is there, some free locations are there and rare is present in the last position. Rare is present in the last position. Then rare is moved to 0th position. Then rare is moved to 0th position. Otherwise, it behaves or the operations are performed like simple queues. Now, this is about NQ. Now, DQ. Similarly, so 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. If a front is present in these positions, it behaves like a simple queue. DQ operation can be performed like this. If a front is present in the last position only, you will get the concept of circular queues. So this is the important in circular queues. So if rare is present in the last position, then rare you have to move to 0th position if free locations are there. Then it is a circular queue. Otherwise it is like a simple queues. If a front is present in the last position, some elements are there, then can be removed by moving front to 0th position. Okay, like that. So NQ and DQ operations are performed. Then how can we know whether Q consisting of some elements or not? So that is possible by using count variable. It counts the number of elements present in the Q. Number of elements present in the Q. So if count equal to 0, Q is empty. If count equal to max, then Q is full. Like that, you can know that whether Q consisting of elements or not. Hope you understand the concept of circular queues. Why we have discussed this one. Simple queues is having some disadvantage. To overcome that, circular queues are used. So now, let us start the implementation of circular queues. Yeah. So now, as usual, include the header file. Declare front variable which is initialized to -1, rear variable initialized to -1, count variable initialized to 0. Now we will perform NQ operation. Which element you want to insert? Some element ELE. Okay, Q full condition. What is Q full condition? If count equal to max, then printf Q is full. Insertion is not possible. Okay, so otherwise else that means there is a space to insert. Then where can we insert? That is based on the position of rear. So if rear equal to max -1, then move rear to 0th position, which behaves like a circular queue. Now incrementation of count and then insert element. Now Q array I am taking like QUE. Then element we have to insert in which position? In rear position element. So declare that Q array also. QUE max. Okay, now if rear is present in the last position, in this way you can perform insertion. Otherwise, like simple queue, that means increment rear, then count is incremented, and then Q of rear equal to element. So this else is closed here, this else is closed here, function is closed here. That is NQ operation. Now DQ. So void DQ now. So if Q consisting of some elements, then only we can perform DQ. So if count equal to 0, then printf Q is empty, deletion is not possible. Okay, then else then how can we delete? That is based on the position of front. If front is present in the last position, then move front to 0th position. Last position, then 0th position element we had to remove. Okay, so now I want to display which element we have deleted. So printf the deleted element is %d, then Q of front. Okay, now if front is not present in the last position, then how can we delete? So it is like a simple queue. That means front incrementation and which element you have deleted. So print that element. That's it. This is a DQ operation on circular queues. Okay, now display. So whenever we display the elements, then only we can know what are the elements present in the queue data structure. So void display. If count equal to 0, then printf Q is empty, display is not possible. Display is not possible. Okay. else now check the positions of front and rear. If now if you observe, see in this, so here if front is present left side and rear present right side, that means front is less than rear, it behaves like a simple cube. Then how can we display? For I equal to front plus 1 to I less than or equal to rear I plus plus. Okay, this is like a simple cube. This is like a simple cube. If front is present left side, rear is present on right side, behaves like a simple cube. So printf simply %d/t, then q of I. Okay. So now, if front is not less than rear, then else. Then how can we display? Then we will display like, see, if this is the case, so this element we have to display and these two elements we have to display. Okay, further two loops are required. For I equal to front plus 1 to I less than or equal to max minus 1 I plus plus, then print. That means front plus 1 position to last position is one loop, and another loop is from 0th position, circular queue na. So from 0th position to rear position I plus plus. Now again print. So now this else close here, this else close here, display. Okay. So now save. So now why in coming to main function, in main function I want to perform NQ operation. NQ of sum 10, NQ of 10, NQ of 20. So like that I want to insert 5 elements. 3, 4, 5. 3, 4, 5 elements. Now I want to display. Okay. Now compile the program. So we have to define max hash define some max 5. Okay, execute, compile. I is not declared here, so declare I, integer I. Save. See, whenever error you are getting, don't worry. So read that error, understand the meaning and rectify. So compile, no errors, run. See, process exited after 0.0 seconds with return value 4 present. So these are the elements present in the queue. But 10 or 20 not displayed. Only 30, 40, 50 are displayed. See, check that. So we will rectify. Here, for every insertion we are incrementing count na. For every decrement deletion operation we have to decrement count. We measure that one, count minus minus count minus minus. Okay, now let us check. Don't worry if you are getting error. Okay, compile, execute. Now also it is displaying only 30, 40, 50. Let us check again. We are getting same 3 elements. That means, see, where can we get the mistake? Where we have written the mistake? Some NQ operation. See, in NQ operation everything is fine. Then check DQ operation. In DQ operation also, if display operation. So front less than rear, front plus 1 to rear. This is correct. But where did we mistake? So here front is initialized to 1. So front you should initialize it to -1. Then compile, no errors, execute. See, now the elements are. Okay, so but we will give the message like the Q elements are printf the Q elements are. Then it is easy to understand. Compile, put semicolon, execute, run. Save, compile, and then execute. See, the Q elements are 10, 20, 30, 40, 50. Now let us check whether DQ performs correctly or not. So call DQ function, again DQ function, again DQ function. 3 times I am performing DQ. Okay, and then display. 3 elements we are deleting and we want to display. Save, compile, execute. See, 10, 20, 30, 40. 3 times we have performed a DQ. The deleted element is 10, the deleted element is 20, the deleted element is 30. Then the Q elements are 40, 50. See, give new line here. Then it is easy to understand. New line. Here also I am giving new line. Then it will print a new line. Now it is easy to understand. Compile, compile, execute. Now see, the Q elements are 10, 20, 30, 40. 3 times we have performed DQ and the Q elements are 40, 50. Easy to understand now? So now, see, another 2 times. Now, till now we are checking, we checked only simple Qs, not circular Qs. Now let us verify circular Qs. See what we have done. So 5 insertions we have done, then 3 DQs, 2 DQs, and then display. Okay, let us check what will happen. Compile, execute. Now 5 elements we have deleted, that's why Q is empty. Display is not possible. Now I want to perform NQ operation. Now you will get the circular Q concept. NQ of some 2 I want to perform. Again another NQ of, this is like again simple Q. This is like a circular Q. This is like a circular Q. Then it has to come back to 0th position. So now NQ of 3. And then we will display. And then we will display. We will check whether it is working correctly. Execute, compile, run. See, Q elements are 2, 3. That means exactly it is working circular Q manner. That means rear is present in the last position. So, front rear is moved to 0th position. Now we will check DQ. Whether DQ performs well. Now it has to delete Q element 2. Now let us check which one, whether it works correctly or not. Compile, execute. See, deleted element is 2, the Q elements are 3. Yes. Now circular queue properties are satisfied. So this is circular queue implementation using arrays. Students, hope you understand how to run the or how to write the program for circular queues. If you have any doubt, please comment to me in comment box. So if you like the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day.